Hello, welcome to another session of data analysis. We continue where we left. As a review, last session we had this activity 1 and 2 because they are very similar to each other. And I ask you, or the activity asks you to create the frequency table regarding the data you see on the right. And after that, it asks you to create the frequency table for the data on the left. And you did it last session. And before we continue with the activities, left activities, two not signs, it should be different. They are full commands. One of them is sum. When you put sum in R, anything you put inside the parentheses, calculate the summation of all the elements of that thing. If it is vector, all the elements are summed up. If it is table, every element in the table is considered for that summation. Another one is diag a table. What happens here? When you give a table, a square type of table, that means the number of rows equal to number of columns. Diag represent the data that I'm showing you now. It's very helpful because usually a specific data are located on the diag of the table, diagonal. And for example, if we have 13, 2, 3, 177, 24, 7, 6, 5. Then you use this command, it gives you the vector of these elements that now I'm showing you on this slide. So if you put the command sum and inside the parentheses that I told you, whatever you put inside this parentheses would be added up. All the elements would be added up. And if I put here diag a table and assume we name this table BB, okay? So if it is BB, the table, sum diag BB calculates this one, 13 to 17, 77 is 90, the total is 95. And it's very helpful, especially when you are working with the data of, or tables of big size. So now you know these two things, and here you are asked to do this activity. It asks you to continue activity 2 by calculation of the prediction precision of the model. Here you see we have 2 columns, my friends. Column of reality and column of prediction. Here, the prediction is wrong because reality is 0 and prediction is 1. It is correct. So here it is wrong it is correct, correct, wrong, 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 correct, and like that. We continue to the rest. Last session, we learned together an improvised or manual type of coding with R to calculate for us this, but it's possible to calculate the precision of these prediction things that you see in front of you with the help of these two commands that we just discussed together. So in fact, instead of checking, because last session we did else if and summation of those things, but other than that, you can use it through frequency table. That is the more popular way of doing it, because when you get the answer with prediction table, it tells you more information about that, how many of the correct predictions are, belong to reality 0, how many belong to reality 1, and how many of wrong predictions belong to 0 and 1. So it gives you so much information, but not so much information, more information than just calculating the precision. So start doing this activity, and after an ample time, I will do it in front of you. You can see it. Now do it on your own and try to calculate the precision of the model you have with frequency table. Just before you start, let me show you a frequency table. Imagine it is your frequency table. $70. Okay, and let's put here 0, 1, 0, 1. What part of what this numbers tell us? Tell us we have 50 correct prediction in 0, and we have 70 correct prediction of 1. So the total number of correct prediction is 120. The total number of wrong predictions is 30. We had, imagine it is reality and it is prediction. And here we had 10 0 cases that are predicted wrongly as 1, and we have 20 cases of 1 that are predicted wrongly as 0. So you see, you have everything now to analyze your prediction model, and also you can use this data to calculate the precision of your model. Now take your time and do it. Okay, my friends, now you can check your answer with the R page that now I'm showing you. First, you get the file. The CSV file is the table. After that, you create the frequency table of that CSV table with this command table. And since the name of the data is A, so $, reality goes for the column of reality, and $, prediction goes for column of prediction. And after that, you get the frequency table as you can see in front of you. How many correct predictions we have? We have 10 correct predictions. We have 10 correct, 7 of them in the category of 0 and 3 of them in the category of 1. And we have 7 wrong predictions. So when we want to calculate, that is the main part of this activity, this formula, you need to calculate the summation of diagonal of frequency table over the summation of frequency table. So you see here we are using exactly all those two, both of two commands that we just discussed in the previous slides. And you can see summation of diagonal of frequency table. This is frequency table, and the summation of these things means 7 plus 3 over summation of all the elements that you see here, that equals to the number of elements of the table that we have. So in this way, you should be able to calculate frequency of any output for neural network. And now we are going to do a thorough activity over that. Okay. Since today we are going to end a very important phase of neural network. So today we are going to finish this comprehensive exercise review together. And we finish this phase. And after that, we start doing other examples together that they are more challenging, and you need to consider different options, because the model that now we are working in is a small model where it has only 3 inputs. It has only 400 observations, but the rules, everything is the same. The other cases is about training. It is not that you get the training this much fast and easy, that we are going to discuss these two things together. Also, we are going to have as part of your third homework that I will publish the description next week for you about the third homework. That would be a collaborative one. Okay, about the activity 4, it asks you in terms of precision, which neural network is better? So far, you have created 2 neural networks. One neural network, I'm talking about the distinguishing part, the different part between these two things. One was, the difference was in the hidden layer. One of them was with 5 neurons. The other one was with 3 and 4 neurons. Here, it asks you which one is better in terms of precision. Precision for what? For training or testing? You see, after this, we have activity 5 that here asks you to analyze the neural network performance with the testing data. It's very easy, these 2 activities that we are going to do in the remaining half an hour, and that would be a good time to cover this activity if you are good with everything that we have discussed so far. So just try to do it and enjoy the process and your dominance on this state-of-the-art technique. And check the results. So here, when it asks you in terms of precision, which neural network is better, it means the training with training data, the one with one hidden layer or the one with two hidden layers. Do the comparison with the command of table. Here it asks you when you want to calculate the precision, use this more advanced type of codes that we just discussed together here. And after that, it asks you, is this conclusion aligned with their SSE? Because you have some SSE outputs for your neural networks. And over there, since SSE is talking about the errors in training, one of them has better SSE than the other one. Here it asks you, is the precision you got is aligned with, is in coordinates is aligned with the numbers that you see here. Okay, before you start the things, please devise a plan in front of you that how you are going to do this. You already have some of the things, but I recommend, since it is there is no need for coding, do everything again. So you need to get the data, the binary data that you have it on Canvas, and you already have it on your computer. After getting the data, getting it normalized. You get the normalized data. After getting the normalized data, do the sampling part. After the sampling, create the training data as well as testing data. When you have the training data, you can make your neural networks. So you create your neural network 1 and neural network 2, one of them with 5 neurons in the hidden layer and the other one with 3 and 4 neurons in 2 hidden layers. Okay, and when you get these things, compute your neural networks 1 and 2 over training data. And when you get these two things, now you are ready to calculate the precision. So do it until here. So you get the output. And when you get the output, just if I want to give you a quick review, the output as we discussed it is not exactly 0 or 1. So you need to finalize the output with that else if, that last session we talked about. Finalize the output to 0 or 1. And when you get that thing, create the table, frequency table over admit column in the training data, and this finalizes stuff. And after that, you compare these two things. Please take your time. And I'm telling you, this session is for this. When you do these things correctly and everything is fine, it means you are in a very good shape in terms of knowledge in the fields of neural network and R. So here we want to compare these two things. And remember, my friends, when you create your neural networks, you train them, check the errors you got, that I'm talking about, that SSEs, and write them somewhere. And from time to time, step by step, I help you with the process by showing you, by doing it on my computer in R. But to start, do it yourself. And I'm telling you, from time to time, I come and do it for you. Feel free to ask if you have any question. Even if you are checking it online, just send me a message and we can talk and discuss anything. And remember, since neural network is a very liberal type of technique because of the wide range of applications, any idea comes to your mind for using neural network and any idea for running an application or using it, anything, you feel comfortable to discuss those things with me. I would be happy to help you with your ideas, especially in the field of computer informatics. Okay, continue with this. Since we have trained many neural networks last sessions and many of them with different settings, I recommend doing it from scratch. So you can be sure with the results that everything is according to what the challenge is asking you. That is a comprehensive review on everything we have done. And just for your, in case you want to have it, you see in front of you, I put those commands, the elementary steps. First, we get the data with read.csv. After that, we start normalizing the data, and we call it normalized data. It's a new table. And we normalize it this way. We discussed it before: normalize GRE, normalize GPA, and normalize rank. And when you get your normalized data that is ready for training, you create your sampling vector. Sampling vector decide with the 80% and 20% of this vector of probability to decide which row of the table must be assigned, must be considered as training data, and which one as testing data. We need to generate 400 random number between 1 and 2 with the probability of 80% and 20%. And the ones with 1, because it is 80%, considered as training data, and the other ones as testing data. In the next line, we create our training data. Training data is extracted from normalized data, but which rows? The rows that have 1 in the sampling vector. According to all those things that we discussed together, I'm not going to talk about the reason we are coding it like this. It is just a reminder. So when you get to this point, it means that you have your training data and your testing data ready. So after that, you can start making your neural network. And by the way, for example, if you need more time to think about those things, to catch up or check something, check your notes, anything, just stop the video and get thing. And after that, let the video usher you to the next step. So I'm just telling you, the next step now is creating the neural network. For the next step, that is creating the neural network, you need to call on a library of neural net. And after that, you create 2 neural network. Here, the formulation for creating 2 neural network are here, N1 and N2. Neural net, according to the syntax, according to the structure, admit, tilde, GRE plus GPA plus rank. After that, we put the training data, the data that we have here. Hidden layer, only 1. Error function is SSE. Linear output is false. It means that that activation function that we talked about is applied, and the output would be between 0 and 1. So we would be in much more control over the data we have. AND1 and AND2 are created. And here you get the first step in the questions, activities, the inquiries, activities, the activity has for you. And it put the plotting of AND1 and AND2, because when you plot a neural network, you can see the errors that I'm going to show you soon. But try to do it on your computer so you can catch up. And I'm telling you, if in case you are behind, just stop your video and catch up. And after that, continue with the video. As you can see in front of you, the error associated with AND1 is 29. AND1 is the neural network with only one hidden layer. Let's go and check for AND2 as well. Your answer could be completely different from mine, because many of the steps here are random, and of course the outputs have trivial differences. Okay, and now we see the error regarding the AND2 is 26. So it shows the performance of the one with 2 hidden layers according to the errors when the training data, based on the training, is better, the second one. Still, we didn't compute anything, but it just said the training experience has been better with the second one. Now it wants to check that the training experience is better. We should expect the precision of the model should be better. That's the things that you are gonna do. I'm just gonna write it somewhere so we can have the errors. And 2 error is 26 and 1 error is 29. Now, when you get to this point, right, and 2 error is 26. We always consider such comprehensive example at the first phase of neural network to make sure everything is fine and you have some sort of holistic dominance, control over everything we discussed. So now we get the performance, and now go to the next step, that is computing the neural network First, you compute it, and after that, because the output for neural networks are many neurons, many layers, we don't want them. We just want the output from the output layer. That, again, we discuss all these things together. The reason I pass over them quickly is that the name of the output neuron is net.result. So we get the output from the neuron, the output neuron. Do you remember I told you about the speculation on all those things that you see? Now you got. So the other things are the outputs of the neurons. That what we want is the output of the last neuron, is the output of the neuron in the output layer. That is net.result. And I told you, when you are good with the technique, if you are good with the program, all those things could be understandable with experience. And you just notice that when it is the output from the neural network, so the other numbers are output from the other neurons. Okay, so you create the output from the last neuron, and after that you finalize it, that if it is greater than 0.5, it is 1, otherwise it is 0. I'm going to show you this round of codes. Here you can see the name, here it used the name output train 1. What does it mean? It means the output of neural network 1, but out of the training data. It means that we use exactly the same data that we use for training our neural network, we use for testing our neural network. That is not but just an exercise. So you see output train 1 equals to compute. Compute, what is your neural network? It is N1. Okay, what is your data? It is training data. So you put everything here and you get it. The same things for the second neural network that you have, that according to the training experience, its performance is better than the other one. When you get this, but we don't want that complicated all outputs of every neurons. No, that's not what we want. We just want the output of the last neuron, the neuron in the output layer. So you get it like this. What is the name of the calculation for your neural network? We just got it. Outtrain1. So from outtrain1, get the items of the column that is called net.result. It is standard. For the other one, other neural network, we do the same, and we finalize it like this. If the number is greater than or equal 0.5, make it 1, otherwise it is 0. So now we have the outputs of our model, our neural network models as well. Now, what is the next step? Just create the frequency table. Now I run that frequency part for you on the R platform. So I put the formula, frequency table 1 related to the neural network first. So table, we put the outtrain1, the output we just calculated, and from the training data, you need to get the admit, the output, the correct output. And that's it. It is frequency table 1. And for frequency table 2, we have outtrain 2, and training data and admits are the same. So now we have these things. Now we just need to, now we have the formula for both frequently table, and if we want to see them, frequency table 1, you see it is the first one, and frequency table 2, it is the second one. And with this formula, we can calculate. So for the first one, it is 70, about 3-4% precision. And for the other one, I just need to make this FT2. And FT2, it is 76.7. So you see, when the experience with that training is better for the second one, also the precision with the training data set is better. So we got the answer for the first question. Now we can return to this Okay, in terms of precision, which neural network is better? The second one is better. Do the comparison with the command of table. We did it with the command of table. Is this conclusion aligned with their SSE? Yes, it is. And finally, activity 5, it says analyze the neural network performance with the testing data. It's very similar to the previous one, just in the training part, you need to put the testing. That I want to finish it. So now just go and check it. And if again, I'm rushing, just stop the video to catch up and everything. And now analyze the performance with testing data. See, what is the story? We trained our data, but we test our data with the training data. Okay, now we want to test our data, our neural network with the testing data. Go ahead with that. Okay, here now I'm showing you the code for, no, you are okay, you are okay. You are okay, just set up. We are just in the last 2 or 3 minutes of recording. Okay, now here we are doing everything with the testing data. Since we already have our neural network that was trained with the training data, so we put that neural network here. And please, at any time, if you have any question, just shoot me an email and we can discuss everything. But if you do every steps just with patience and check everything, it would be very smooth process. And as we did it together, this comprehensive exam. So here now we want to see the performance of our neural network with the testing data. So compute neural network, but here we put the testing data and out test one. And we do the same thing with the second neural network, but we just want to get the last layer output. And after that, we finalize it to 1 and 0. And at last, we get our frequency table with this formula that you see in front of you, that I'm gonna do them with R in front of you before we end our class today. I'm not sure, did I show you this page or not? So just, oh yes, I showed you. I showed you, share. Okay, now We get frequency test 1 as these. They are for testing data. And frequency test 2 as these. And so we can calculate the precision to see the performance. For the first one, frequency test. FT test 1. So it is 71.2%. That's a good performance on testing part. So it means that our neural network performance is very good over training and testing data. And it is not overfitted because they are close numbers. And let's check it for the second neural network. And you see they are the same. Okay, thank you so much. Have a great time.